Hi everyone. In this video, let me talk about the key pointers that you must have on your fingertips in order to solve any kind of P3 differentiation question very comfortably. First things first, differentiation itself is a very small topic in P3. As such, differentiation is not hard if you ask me. What is hard that students feel is the process after the differentiation. Let's say if you're supposed to find the x coordinate of the curve. So in that case, you need to find dy dx equal to 0. Sometimes dy dx looks very complicated, but then if you follow just one approach of taking the common factors and then equate it to 0 and say that, okay, this is also equal to 0 or this is also equal to 0. And then if you try to solve it, you will feel that, okay, yeah, now it's a bit manageable. So yeah, usually students who are not really good with the manipulations of the trigonometric terms, algebraic terms, logarithmic and exponential terms are the ones who usually struggle. The people who are comfortable with this, I've seen, usually they don't struggle with this topic at all. It is that easy. So this brings us to a question that how do you become better at these manipulations? So answer lies in practicing as many differential equation questions as you can, because differential equation don't just help you master the trigonometric and all of these manipulations, but it also makes you revise the concepts of your integration altogether. So I highly recommend that you practice differential equation, and more than 50% of your syllabus just keeps on getting revised over there itself. So yeah, I'll talk about more on this when we talk about the differential equation chapter. For now, let us focus on the key pointers of the differentiation. So the first thing is you must know how to differentiate all of the terms mentioned over here, that is exponential term, log term, then the trig term, and the arctan term. Then how do you differentiate the sec x, cosec x, and the cot x that you have learned in your, of course, trigonometry with the help of quotient rule? Because I know that sec can be written as 1 by cos. So now it's in the format of p over q or u over v. Now you know how to implement your quotient rule and differentiate this very easily. Now this becomes very important. If you know how to differentiate this, you will see a lot of questions in your past paper. They also ask you to then integrate it and get the answer in form of sec x, cosec x, and the cot x. So it's a really good thing that you practice it beforehand, that how to differentiate these guys with the help of quotient rule. Then of course, along with the quotient rule, you should also be good with the product rule, where product rule is basically if you are having u dot v, two functions multiplied with each other, you can differentiate this with the help of, let's say if you are differentiating u first, keep v as it is. And then if you want to differentiate v, you keep u as it is. That is your product rule. What is your quotient rule? Your quotient rule says that if you are having a format of u over v, and if you want to differentiate this, you differentiate the first function that is in the numerator, keep the denominator as it is. Now a subtraction comes. Then you differentiate the below term that is in the denominator and keep u as it is, and then divide it by v square. So if you're aware about these rules, of course, all of these things are mentioned in your MF19 formula booklet. But I'm a big fan of having this on your fingertips. The more you are having things on your fingertips, the less you will have to worry in your final examination. So practice accordingly. And then the last thing is you should be good with the parametric and the implicit differentiation rules. In parametric differentiation, you should know that if x is given something in terms of t, if y is given something in terms of t, then how you can easily find dx dt over here, how you can find dy dt over here. And then if you want to find, let's say, dy dx, how you can do this using dy dt over dx dt. Or in the other way, you can also write dy dt into dt dx, whichever way you are comfortable with. So if you're aware about these rules, you can find the differentiation, and once you're having differentiation, you can also use it for the application of differentiation. And then the implicit differentiation. This is where you are having a mixture of your equations where x and y are together like this. And then you are supposed to differentiate this with respect to x-axis. So you should be aware about that whenever you are going to apply differentiation on the y terms, you differentiate it like 2y, and then that's not it. You also need to multiply it with dy dx, because you are differentiating with respect to x, not y. So over here you have differentiated your y, and then you have multiplied it with the dy dx to show that yeah, it's with respect to x-axis. If you are not aware about this, I'll recommend you to check the topic of implicit differentiation. But yeah, even the implicit differentiation is not a big deal. With just 2-3 questions and you will just master it. And then of course, once you are done with this, you can go ahead and apply the differentiation to find the equation of the tangent, normal, or the stationary points. That is the application of differentiation. And in the upcoming videos, I'll show you the different types of questions that could be asked with respect to the topics that I have covered over here. And yeah, if you are able to solve all of these questions, then of course, a similar type of questions which are very common, you will be able to solve it very comfortably in the examination. So yeah, I'll see you in the upcoming videos.